Uh, Hi everyone. It's an honor to be here today, and I would like to share our insights on our research that is data-driven clustering of smart farming to optimize agricultural practice to machine learning. My name is Pattharaporn Thongnim, and I represent the Department of Mathematics at Burapha University, Thailand. Our work focus on integrating advanced data science techniques into agricultural to a new farming practice. In Southeast Asia, particularly Thailand, is known for its rich variety of tropical fruits like durian, mango, mangosteen, and longan. So, the farmers nowadays face increasing challenges such as climate change, extreme weather, and the need for sustainable farming method. This challenge demand innovative solutions such as the use of technology and data-driven practice to improve productivity while maintaining environment's balance. Oh, sorry. For introductions, agricultural have always been the backbone of our society in Thailand. However, with increasing challenge, as I told you before, it has become essential to move towards smarter farming practice. This is where data and technology should play a transformative role. By studying data-driven methods, we can enhance productivity and efficiency in farming in the east part of Thailand. This picture is the durian farm at Chanthaburi, and we use like technology in this farm, right? IoT, drone, and sensor, and use the data to analyzing for productivity and fertilization. Today, I will walk you through the methodology, analysis, and the finding from our research focused on optimizing durian cultivation in Thailand. This is some parts of our research. At first, we have to collect the data, right? We collect the data from the data center at Chanthaburi and Regional Office of Agricultural Economics 6 at Chonburi. We collect the data from 6 provinces in Thailand from 2012 to 2023. And normally when we have a good or perfect data, when we select a good model, and that's mean like the performance in this model is so good as well, right? And in this research, we would like to compare between original data and when we use transforming data and then model, and we would like to think about data transforming is important for the data or not, right? And before, when we use transforming data, we have to understand or we use min-max, like we use min-max scaling, we use set score scaling, but the log transform, and when we can change the attribute as well, right? And the good thing, and when we use transform, like for example, we can handle skew data, like log transform can make it more systematical and closer to normal distribution. And maybe we can deal with the ratio and percentage when you are interested in relative chains rather than absolute chain. Log transform are natural to use. And we try to control and variance as well. Log transform can help make the variance more consistent across the range of value. And we can say like homoscedasticity. Or we can make pattern more visible. Sometimes pattern in data become more apparent after log transforming, after we use log transforming. And this we use the model like unsupervised learning, that is clustering analysis, to to use this to find the group of the data. We use the K-mean clustering algorithm to group farm based on their performance and maybe the characteristics. The algorithm partition data points into cluster by minimize the within cluster sum of square, ensuring cohesive and meaningful group as well. We use the elbow method help us to determine the optimal number of cluster by evaluating how the WCSS sorry with it can decrease with additional cluster. For validating cluster quality, we use metrics such as silhouette score and elbow method, something like that. For performance metrics, for clustering evaluation, we use Davies-Bouldin Index, Dunn Index, and silhouette score as well. And for this is data visualization. We would like to use Blockpot, and we try to find the pattern of the data for area of production and use. And in the left hand side, we can see like we have like 6 provinces in there in the picture, and we compare between average area of production. And you can find Chanthaburi have the most area in the east part of Thailand, yeah, and then like Rayong and then Tat. And then nowadays for the use, okay, the most used in the east part is Chanthaburi and then Tat and then Rayong. And this you can see what the province is very popular for, like for produce like durian farm and for produce the production and use in the east part of Thailand. This is we use histogram to like when we use log transform for transform the data for area of production and in this variable, maybe when we transform area of production, maybe it's better when we use like the model after this. So however, this is like QQ pod when we would like to compare the original data and when we use transform for area of production, like in the right hand side, we can see look like normality more than in the left hand side. Maybe this transform is better when we use this. But for when we use log transform for you is not better. It's not look like normality in the QQ pause as well, it's look like it's not better for this. The question for the transform data is like log transform data provide better defined forecaster or not. That's why we want to compare between original data and log transform for machine learning. And this like the cluster assignment of province, and we just give the example like 2012, 2017, 2012, and 2023. In the last one is like we can separate group of like province and like districts as well. And we give more information in the paper why they change between the years. And this is when we compare between clustering metric before and after. When we use log transform, we use metric like the Davies-Bouldin score and Dunn index and silhouette score, right? And this we can separate the cluster like for T clustering. When we use like K-mean clustering, our research analyze durian production data from 2012 to 2023. We can identify the main cluster of durian farm, cluster 0, large scale, high yield producing, cluster 1, small scale with low yields, and cluster 2 is medium scale farm with moderate yield. The clustering reveal actionable insights such as region with high productivity that could serve as model for best practice. Additionally, the finding highlight area where target interventions such as improved resource allocation or, or advanced farming technique can significantly impact productivity. This is the table show the cluster assignment for independent province and district based on the durian production data from 2023. Each row represents a province and its respective districts categorized into one of the three clusters identified in the analysis. The clusters are different by shared characteristics such as production area and yield with cluster 0. Typically representing province with large production area and high yield, while cluster 1 and 2 represent province with smaller production area and varying productivity level. So when we use these techniques, we find out the transform technique is not necessary for this data. That's why we can use original data to use after to use for the model for unsupervised learning, such as like gaming clustering as well. So the research also compare cluster method like before and after log transform that I showed you before. The log transform does not consistently improve clustering quality. In some cases, the original data produce better defined cluster. And that is important to understand the data set structure before applying transformation as well. For the future, while our current work focus on clustering, the potential of machine learning is agricultural in like a variety and is very big. I think the future step maybe I should use like the data for the real time with IoT sensor and try to predict like the productivity and like try to find out the optimizing algorithm for irrigation and fertilization use. In conclusion, the intersection of data science and agriculture offer endless possibility. By using machine learning, we can not only address current challenges but also pave the way for sustainable agricultural future. So I invite all of you to join hands in promoting smarter data-driven farming practice in Southeast Asia. Together, we can create a more resilient and efficient agricultural landscape. Thank you for your time, and I look forward to your question and discussion in the future. Thank you.